right, here we are with 1.4, solving absolute value equations. Let's look at the core concept first. And before I totally get started, make sure you know, yes, you do have to write everything on every slide. I know there's been questions, and I'm just telling at the very beginning of this notes video, you must write everything on every slide. All right, so properties of absolute value. Let's just look through this. The first one, first of all, it says let A and B be real numbers. So that means they can be any number, real numbers. Then the following properties are true. If I take the absolute value of A, it is greater than or equal to 0. So taking the absolute value just makes whatever's on the inside come out to be positive. For example, if I were to take the absolute value of -3, that's going to come out to be +3. So the absolute value of A is greater than or equal to 0. Then, if I take the absolute value of -A, that's equal to the same thing as the absolute value of A. So if I take the absolute value of -3 and the absolute value of +3, then they're both going to equal 3. It doesn't change the sign from positive to negative, negative to positive. It doesn't switch. It's always going to come out positive. Also, number 3 here, if I have the absolute value of A times B, that is equal to, I can split it up into two separate absolute values, the absolute value of A times the absolute value of B. For example, if I took the absolute value of 20, I could rewrite that as the absolute value of 4 times 5, all in the same absolute values, in the same set of bars. So that's absolute value of 4 times 5. That is the same thing as saying the absolute value of 4 times the absolute value of 5. So you can split them up and you can put them back together as well. The same thing goes for division. If I have the absolute value of 5 divided by 4, I can split that up into the absolute value of 5 divided by the absolute value of 4. The only stipulation here is that b cannot equal 0. So on the bottom of your fraction, you cannot have a 0. Now, using some of that information, we are going to look forward into solving absolute value equations. Now, to solve an absolute value equation, if I have the absolute value of ax plus b and it's equal to c, if c is greater than or equal to 0, so that is a very big must. C has got to be bigger than 0 for us to proceed with this. We're going to solve the related linear equations. The first one is going to be ax plus b equals c. The second one is ax plus b equals -c. So where this c is positive here, we're going to write a positive version and we're going to write the negative version. So every single time we solve an absolute value equation, if c, the end number, is greater than or equal to 0, so it's got to be positive or 0, then we're going to split it up and write two separate linear equations to solve. So if c is less than 0, the absolute value equation has no solution because absolute value always indicates a number that is not negative. So if I take the absolute value, just like we set up here, it has to equal something positive. So if it says it's equal to a negative, then there's no solution. All right, let's use some of that information and move on to example 1. Make sure on the top of your notes you have your title, which was on the previous slide as well, Solving Absolute Value Equations. Make sure you write down that this is section 1.4. So example 1, yes, write down all of the directions, write down the problem. Example 1 says solve each equation. Graph the solutions if possible. So here we go. Absolute value of x minus 4 equals 6. Our first question here is this number over here positive? Is it bigger or equal to 0? It's bigger than or equal to. So yes, it is bigger than 0, so we can move on. And what we're going to do is we're going to take what's inside the absolute value and write down x minus 4. Just pull that out is equal to positive 6. And then we're going to come over here and write down x minus 4 is equal to negative 6 as well. We have to solve both of these. So a while ago it said or, so we're going to put our or in there. Now, how do you solve this linear equation? Well, if it's minus 4 right here, then I'm going to add 4 to both sides to get x by itself. Those 4's are going to cancel, and then I have x is equal to 6 plus 4 is 10. Over here, I'm going to do the same thing, same steps. It's minus 4, so I'm going to add 4 to both sides. The 4's on the left side cancel, and I have x is equal. Now this time I have negative 6 plus 4. So if you need to use your calculator, feel free, but that's going to come out to be negative 2. So again, make sure you have your or there. Now, when it says graph the solutions if possible, well, it is possible to graph these solutions, and we're just going to graph them on a number line. So here's our number line here. What is the smaller of the two numbers? Well, if I've got a positive 10 and I've got a negative 2, then negative 2 is the smaller of the two numbers, so it's going to go on the left. The positive 10 is the larger of the two numbers. It's going to go on the right. There's no shading whatsoever. I'm just putting a solid point or a solid dot on negative 2 and a solid dot on 10. It's not greater than or equal to or anything like that. It is just simply the graph or the number line with points on each of those. So again, make sure, some of you are forgetting, make sure to highlight your answers. We have x equals negative 10 or x equals negative 2, and we also have our number line. Make sure that's all highlighted. All right, let's do another one. Part B, absolute value of 3x plus 1 equals negative 5. So remember, the absolute value makes everything positive. Can it equal a negative? And the answer there is no, it cannot equal a negative. So our answer here is no solution. Anytime you have one like that, remember you are supposed to write down the problem. So I want you to make sure if it is a no solution, just as I did here, make sure you draw a little arrow to that negative sign. And that way we're saying, hey, it is no solution because that's negative. So just point that out there whenever you write down a no solution for that reason. All right, example 2. Example 2, we have absolute value of 3x plus 9. Now we have a minus 10 equals negative 4. Some of you, because of the last example, are going to be saying right off the bat, hey, this is negative. It's a no solution. That's not true, because even though that's negative, we also have a minus 10 right here. The absolute value has to be by itself for us to determine if it's no solution or if it's solvable. So to get that absolute value by itself, we're going to go ahead and add 10 to both sides. The negative 10 plus 10 is going to cancel. And now I have the absolute value of 3x plus 9 is equal to, well, negative 4 plus 10 is the same as 10 minus 4, which is 6. Now, absolute value equals a positive, so we're good. We can split it up, and it's okay. So 3x plus 9 equals positive 6, or 3x plus 9 equals negative 6. Make very sure that you are using both of them. Now let's go ahead and solve these. So the first set, we're going to subtract 9 from both sides of our equation. And we are left with 3x is equal to 6 minus 9 is going to give us negative 3. Go ahead and divide. So whenever I divide here, I'm dividing by 3. Divide here, I'm dividing by 3. That's going to cancel. And I now have x is equal to, well, negative 3 divided by 3 is negative 1. or we're basically having the same steps here. We're just going to have a different outcome. I'm still going to subtract 9 from both sides. I'm still going to get 3x on the left side equals, but now I have negative 6 and negative 9, which is going to give me negative 15. Same step as before. I'm going to divide by 3 on both sides. And now I get x is equal to, well, negative 15 divided by 3 is negative 5. Excuse me. This one did not say graph if possible, it just said solve. So there we go. We have x is equal to negative 1 or x is equal to negative 5. So there's our answer. Okay? Yes, you have to write the whole problem. It's only 3 sentences. It looks like a lot because I have large print, but it's not very much. In a cheerleading competition, the minimum length of a routine is 4 minutes. The maximum length of a routine is 5 minutes. Write an absolute value equation that represents the minimum and maximum lengths. We're going to go about this a little bit backwards than what we worked the other 2 problems or 3 problems out. But the first thing that we're going to do is we are going to write down a formula. I need you to make sure you make note of this formula, remember this formula, flag the page, whatever you need to do. So we're going to have absolute value of x minus the average is equal to the maximum minus the minimum divided by 2. Okay, so right here, if I use the numbers in this problem and I put them on a number line, you don't necessarily have to, but it's going to help us work this problem out. In a cheerleading competition, the minimum length of a routine is 4 minutes. So there we go. I'm going to put the minimum right there. That's 4. Then the maximum is 5 minutes. So I'm going to put that on my number line as well. And I have to write an absolute value equation. Well, right here, if I have my min and I have my max, how do you find the average? Well, to find the average, you add them together and divide by 2. So the average is going to be 4 plus 5 divided by 2. Well, 4 plus 5 is 9 divided by 2. So that means that my average is 4.5. Well, it's halfway in the middle. Okay? So when I write my equation, I have the absolute value of x minus that average, which is 4.5, and that's equal to, now I need the maximum minus the minimum divided by 2. So my maximum is 5 minus my minimum is 4, and I'm dividing by 2. Well, 5 minus 4, let me go ahead and rewrite the left side here. 5 minus 4 is 1 divided by 2, so there's 1/2. You can leave it as a fraction, or you can write it as a decimal. Absolute value of x minus 4.5 is equal to 0.5. The reason that it's okay here to write this as a decimal is because you already have a decimal in your equation as the 4.5. And it's real world. Typically, real world application, you're allowed to write decimals. Okay, here we go. Moving right along. Our next core concept, yes, you need to write this all down. If we have an absolute value on each side, so we've got 2 sets of absolute value bars. The absolute value of ax plus b equals the absolute value of cx plus d. To solve that, we're going to just drop the bars and write it down. Ax plus b equals cx plus d. We have our or, and then we're going to write it again, but we're going to put a negative and parentheses around the right side. And then we're going to solve both sides. All right, so let's now look at example 4, where we have the absolute value of 3x minus 4 equals the absolute value of x. Well, just like previously stated in that core concept, you have an absolute value on the left and an absolute value on the right. So we're going to just drop the bars and write 3x minus 4 equals x, or we're going to drop the bars and write 3x minus 4 equals, and then we're going to put a negative and a set of parentheses around the right side. So we'll come back to that right side here in a second. We're going to work the left side for now. Let's go ahead and make sure we are getting all x's on the same side. So right here, we are going to subtract x from each side because I've got x's on both sides of my equation. So we're going to move them to the left. They cancel on the right, which leaves me if I have x minus x, that leaves me with 0. So then here I have 3x minus x, that leaves me with 2x, and I still have my minus 4. Don't forget your equal sign. Now it's just a typical equation. I can go ahead and solve. Add 4 to both sides. The 4's cancel. Now I have 2x equals 4. If I have 2x, that's really 2 times x, so the opposite of multiplication is division. Divide by 2 on both sides. And then we have x is equal to 2. So there's the first one. Or, let's move to the right side. Before I can move on with the right side, I have to distribute that negative sign into my parentheses, which this time it's easy because there's only one term. So now I have 3x minus 4 equals negative x. So on this step, instead of subtracting x from each side like I did on the left side, I'm going to add x to each side because the opposite of negative is positive. So I'm adding x to both sides of my equation. 3x plus another x gives me 4x. I still have my minus 4 that it's going to drop down there. And then I have negative x plus x. Those cancel, which leaves me with 0. So there again, just like over here on the left side, we have a regular equation we're going to solve. Add 4 to both sides. The 4's cancel. And we have 4x equals 4. Now you can divide both sides by 4. The 4's cancel. And x equals 1. Because of this being off and me being particular, I'm going to rewrite this and put x equals 2 or x equals 1. Now, I did not say anything about graphing, so we're good there. We just have our answer here. Also, and I said something about me being particular, you've all seen that yes, I am pretty particular on how things are written. Make sure that it's pretty even, make sure that it's neat, make sure that it's spaced out. Do not cram it all together in your notes, and do not cram it all together in your assignment either. All right, part B. Again, we have an absolute value here and here. This time we have a 2 on the outside, and I'll show you how to address that. So we have the absolute value of 4x minus 10 equals, I should have dropped that bar there. Sorry about that. All right, so drop the bars. 4x minus 10 equals 2. Now we're just going to put parentheses times 3x plus 1. Or, for the other one, we have 4x minus 10 equals, put your negative in there, then you have your 2 with your parentheses, and then 3x plus 1. So the negative is the only new thing. We just have to make sure we put that in front of the 2. All right, so let's go ahead and solve. Before we solve, we have to distribute this 2 into the parentheses. So we've got 4x minus 10 equals 2 times 3 is 6x plus 2 times 1 is 2. Move all of your x's to the left. So we're going to subtract 6x from both sides of the equation. So 4x minus 6x is going to give me a negative 2x minus 10 equals 2. Now you can add your 10 to both sides of the equation. And we have negative 2x equals, well, 2 plus 10 is 12. Go ahead and divide both sides by negative 2. And we get x is equal to negative 6. Or, let's go back up and solve the right side. Before we can solve the right side, we have to distribute not a 2 this time, but a negative 2. So, we have 4x minus 10 equals negative 2 times 3x is going to be negative 6x. Negative 2 times 1 is negative 2. So now let's go ahead and move all of our x's to the left side. We have a negative 6x, so we're going to add 6x to both sides. 4 plus 6 is going to give me 10. X minus 10 equals, they cancel here, and then I'm left with minus 2. Now keep on solving. Add 10 to both sides of the equation. And we get 10x equals negative 2 plus 10 is positive 8. Now you have 10 times x, so we are going to divide both sides by 10. Cancels. And we have x equals 8 divided by 10. The only problem with this is that if you have 8 divided by 10, that reduces. So we're going to go ahead and reduce that, which means that we're going to rewrite our whole answer. We've got x equals negative 6, or x equals, and to reduce, you can put that in your calculator, or you can just see what would divide into both of those. Well, this is going to reduce to 4/5 because both of those are divisible by 2. Again, you don't have to know how to reduce that in your head. You can put it in your calculator, and the calculator will reduce it for you. All right, there we go. Example 5. Solve 2x plus 12, the absolute value of 2x plus 12 equals 4x. And this one says check your solutions. The previous problems have not said to check your solutions. So there's a reason for that, and we'll go through and we'll see why. So when we set this one up, we have 2x plus 12 equals positive 4x, or we have 2x plus 12 equals negative 4x. Sorry, I'm trying to just write the negative in a different color. Okay, so now let's just go ahead and solve. Once we solve, we'll get our answers and we'll go through and look at what the differences are. Go ahead and get all x's on the left side. So we're going to subtract 4x from both sides. We get negative 2x plus 12 is equal to 0. Go ahead and subtract 12 from both sides. So we get negative 2x is equal to negative 12. Divide both sides by negative 2. And x is equal to positive 6. Or, on the right side over here, we have 2x plus, timeout. We don't have to distribute anything because this is just negative and 4x. So we don't have to rewrite that yet. Let's add 4x to both sides. Sorry about that. Okay, so on the right side they cancel. 2x plus 4x is going to give me 6x plus 12 equals 0. Go ahead and subtract your 12 from both sides, just like before. The 12's cancel, and we have 6x is equal to negative 12. Go ahead and divide by 6 on both sides, and you get x equals negative 2. Now, this one said to make sure you check your answers. So, when we check our answers, we're actually having to plug those answers back in to the original equation. The original equation was the absolute value of 2x plus 12 equals 4x. So let's check the first one here. I'm just going to put a CK for check. When we check that, we're just plugging 6 in for every time that there's an x. So I have the absolute value of 2 times 6 plus 12 equals 4 times 6. Okay, well 2 times 6 is 12, and 12 plus 12 is 24. So I have the absolute value of 24, and 4 times 6 is 24 also. Well, if I take the absolute value of something, it comes out positive, so 24 equals 24. That is correct. Therefore, I'm going to go up here and highlight x equals 6, because that makes that answer correct. Now, let's go over here and check the right side. So on the right side, I'm still going to use the same equation. Absolute value of 2x plus 12 equals 4 times x. Plug in the answer that you got. 2 times negative 2 plus 12 equals 4 times negative 2. So let's work that out. 2 times negative 2 is negative 4. Negative 4 plus 12 is positive 8. 4 times negative 2 on the right side is negative 8. The absolute value of positive 8 is 8. Does 8 equal negative 8? And the answer there is no, it does not. So that is not true. Therefore, I'm going to go up here and put a slash through that number. Now, I want you to go ahead and highlight that. I am checking for that answer because I want to know that you actually did go through and check and found out that x equals 6 is correct and that x equals negative 2 is not correct. All right. Last one. I know this is going to be another long video. I'm so sorry. It's 28 minutes so far. Last problem right here. So x plus 5 equals, absolute value of x plus 5 equals absolute value of x plus 11. Go ahead and drop your bars. X plus 5 equals x plus 11. Or x plus 5 equals negative times x plus 11. Okay, let's go ahead and solve. So right here, we are going to subtract x from both sides so we can get all of our x's on the left. When we do that, the x's cancel. They totally and completely cancel out. All I'm left with right there is 5 equals 11. And does 5 equal 11? The correct answer there is no, it does not. I'm going to write the word false right there because 5 does not equal 11. So we can't go any further on that side. Now, on the right side, we can go ahead and distribute the negative. So we have x plus 5 equals negative times x is negative x. Negative times 11 is negative 11. Now let's solve. Add x to both sides because I'm moving all x's to the left. On the right, they cancel. If there's no number in front, remember that there's a 1 there. So 1x plus another 1x is going to give me 2x plus 5 equals negative 11. Go ahead and subtract 5 from both sides. And you have 2x is equal to Negative 11 plus negative 5 is negative 16. Divide both sides by 2, and you get x equals negative 8. Again, there's a couple of different answers here that I want to see. I want to see where you put x equals negative 8. I also want to see where you put 5 does not equal 11 and that is false. Okay? So even though that doesn't give us an actual answer, it does give us something to look for. All right, that's it for 1.4.